T-shirt.
Thank you. Thank you very much for the warm
Go for it.
presentation. Hello, everyone. I'm really excited to be here tonight at Moldova Developer Conference, not for the first time, but for the first time on such a great stage, surrounded by all of you nerds. And tonight I'm going to tell you about something that is going to change the way we think about web development these days. It is WebAssembly. So before you roll your eyes thinking, well, great, another buzzword, I want to stop you right there, because it's not. It's not a passing trend. It's really a game changer, and I'm going to show you why. A quick question to you. Have you ever tried to run something complex, like complex application in the browser, and noticed that everything is getting slow and sluggish and, well, unresponsive? I believe it happened many times. So that's why we need WebAssembly this day. And I'm going to show you how your code can work like at least 5 times faster than before. Yep. WebAssembly is supposed to break the limits of the traditional web applications. And by the end of the session, I will not only explain you how it works, but only where do we need it, and we'll show you some interesting use cases, real-world use cases, and also a short demonstration of how it actually works. So the big question is, why do we even need WebAssembly these days? We already have JavaScript, right? And it's been around for forever, basically. So why do we bother learning something new? I will paint a picture for you. JavaScript is like a Swiss Army knife. It's versatile and can do a lot of things, but what happens when you need something more specialized? Something like 3D games in your browser, or heavy scientific simulations, or something like that. That's actually where things get tricky. Have you ever tried to load something complex and it become really unresponsive, really slow, clunky, and frustrating, and you look like a guy on that picture? And probably you sometimes make something really heavy, like heavy computational task, or rendering complex graphics in the browser, and it's happening quite slow. Imagine running a Photoshop in your browser, and everything is happening like in slow motion, like that sloth on the screen. And you're just sitting there, no matter how much you optimize it, it's just not working, and you're thinking, why it's not working? So that's where WebAssembly comes in. It is lightning fast, basically. And I will explain you why. It also a really important thing that it's also quite secure. It brings a lot of security benefits, because WebAssembly code runs in a sandboxed environment, which is totally isolated from your system, the rest of your system. And even something goes wrong, like some malicious code tries to sneak in, WebAssembly keeps it contained and locked down. So pretty cool, right? One more important thing, it is cross-platform. You can write your code in languages like C, C++, Rust, Go, many more, then compile it to WebAssembly, and it will work in the browser, on the web. That's also pretty cool. So to sum it up, what WebAssembly gives us? It is speed, like it's near-native performance, like your desktop applications usually work. It is security, and it's compatibility, meaning you can write in multiple languages. What else? But before we dive deep into how WebAssembly actually works, let's take a step back and discuss why JavaScript can be quite slow, especially at some specific tasks. First of all, JavaScript is interpreted language, right? Which means that browser has to read it line by line and execute it as it goes. It also, well, modern JavaScript engines like V8 in Chrome or SpiderMonkey in Firefox are really, really good at optimizing it, optimizing execution of JavaScript, but that's so much they can do. Another important thing that JavaScript is dynamically typed, meaning that browser has to figure out things like variable types during the execution of the code. This creates a huge overhead. And, well, JavaScript is flexible, but flexibility comes at a price, performance. The next thing, does it work? Yep. The next important thing is that JavaScript is single-threaded. It works in a single-threaded environment, meaning that it can only perform one task at a time. And when it comes to heavy computations, it's leaving not so much room to breathe. That's why things become sluggish and slow, and so on. So that's where WebAssembly comes in. From the machine's perspective, WebAssembly is totally different from the JavaScript, because JavaScript is high-level, human-readable language, which should be converted by the browser to the machine code, while WebAssembly is already in a machine language, machine code, which should not be converted in any way. That's making things really fast. But how it actually works, you can write your code in many different languages. It supports a lot, I will show you later, and then compile it into WebAssembly format. It's a binary format, meaning that it will be downloaded faster by the browser, but not only smaller file size or compact binary form makes things better, but it also will run almost immediately by the browser, skipping all those interpreting or optimizing steps. So, as I thought, WebAssembly is precompiled, meaning that it is a set of very efficient instructions that can be run directly on the CPU. Browser doesn't have to analyze what your code is doing or optimize it on the fly. It just simply runs it, and that's making things much more faster, skipping all those steps that actually slows down JavaScript. Another important thing that these instructions are very efficient, and that also make your code run much faster, significantly faster. Later, I will show you the real-life example, how much faster it actually does. And another important, really cool thing, that it also can run in parallel. So unlike JavaScript that is stuck in that single-threaded world, WebAssembly can perform multiple tasks at once, making things, especially on heavy computations, making it much more easy and much more effective. So to sum it up, JavaScript is interpreted language, and it's flexible, but flexibility is also creating some overhead. It's dynamically typed, so browser has to analyze everything, and it also slows it down, while WebAssembly is precompiled with near-native performance, and it can run in parallel, unlike JavaScript that is single-threaded. I believe it's time for a short demonstration how it actually works. I've chosen Well, do that. Let's create two programs in two different languages, like JavaScript and WebAssembly, with the same algorithm. For this task, I've chosen the simple recursive function. I didn't want to show you pages of code, so it should be really simple and small. I really know that calculating Fibonacci sequence with recursive approach is not effective at all, thank you. But it's great for a demonstration. So there is, on the screen, yep, you can see it. There is a simple Rust program, a really simple function. I won't dive deep into Rust, but I believe that it's pretty readable and understandable. It's pretty simple. Basically, it returns 1 if n is equal to 0 or 1. Otherwise, it calls itself recursively and returns the sum of two previous Fibonacci numbers. So to build that Rust code into WASM model, we use a WASM utility. I also created a small repository for this project with some instructions on how to build it. So you can try it yourself later, and the link and QR code is on the screen. Then that WASM utility converts that program into WASM model, and it also automatically creates a JavaScript bindings, so we can easily import that function in our code. Below, you can see in the red rectangle, that's the same function in JavaScript. It's just one liner and basically just the same. It's pretty simple as well. Then we click a button, run both functions, and compare the execution time. I cannot do it live right now, so you will have to believe the next screenshot. And as you can see, WebAssembly performs this task almost 6 times faster. Isn't it impressive? And it's really simple example, a really simple program. Imagine the gains you will get on complex computations. And also, I already said, you can try it yourself later, just take your time. So one more important thing is portability. As I already said, and will underline again, you can write your code in languages like C, C++, Rust, C#, Dart, Go, Kotlin, Swift, many more, and new implementations appear almost like every month. And then compile it to WebAssembly actually, but run it on the web. That gives us a lot of new possibilities, like you can reuse your existing code from desktop application or even a game and just simply run it in your browser. That's really impressive, and it's a really huge time saver. And one more important thing, that it runs like everywhere. Doesn't matter what browser or platform you are on, Chrome, Safari, Firefox, Edge, they all support WASM, so you can run it. You can write it once, compile it once, and run everywhere on every platform, every browser, whatever. It's also really cool. You do not have to rewrite everything in JavaScript and adapt it for different platforms. One more important thing that we all care about is load times. It's really important because have you ever tried to click a link and then page simply loads forever? And it's really frustrating, right? So WebAssembly modules are usually much smaller than JavaScript files. That means that browser can download them much faster. And not only that, and it can also start executing it much faster, almost immediately, skipping all those interpreting and optimizing steps. And that gives a good impression and makes not only users happier, but developers as well, of course. So to sum up, key advantages of WebAssembly: it is speed, like near-native performance. It is portability. You can write in multiple languages and run it everywhere. It is smaller, faster, meaning smaller file sizes, faster load times. It's like converting or upgrading your bike to a rocket ship, and suddenly you can go way faster and reach the places you never thought possible. So, really important question is what WebAssembly can actually do. I'm going to show you some real-world examples, use cases, where WebAssembly already makes a big impact. But before that, when we were rehearsing this presentation with our incredible host and coach, Roman, he asked me a simple, classical question. If it runs Doom. I believe you all know that meme. So the answer is yes. It actually can run Doom free with some solid 60 frames per second rate. And right in the browser, some people did it. So talking about gaming, now you can run high-performance 3D games right in your browser. No installation required. No need to download some desktop app or console version. And Unity, the most, one of the most popular game engines out there, already supports WebAssembly, meaning you can create a game in Unity and compile it to WebAssembly, and your users can run it directly in their browser. It's pretty cool, right? Now, talking about something a bit more productive. Have any one of you already used, or someday used Figma? Yeah, I see. I thought so, because it's really popular design tool, which runs in the browser. It's cloud-based, and actually, Figma uses WebAssembly under the hood, especially when it comes to heavy, complex graphics or real-time collaboration. And it looks and works like a desktop app, but is living completely in your browser, and it's lightning fast and very responsive. Another interesting thing that might surprise you is scientific calculations and real-time data analysis, or even machine learning. Some tools like TensorFlow.js, probably also heard about it, which used to run machine learning models or neural networks in your browser, also uses WebAssembly to get some performance boosts. And it works pretty well. The next one is scientific simulations. WebAssembly also makes some big waves in the field of bioinformatics. Their tasks are traditionally really heavy because something like DNA sequencing require processing enormous data sets. And traditionally, it needed like desktop applications or even some server-side computing. Now, DNA sequencing, processing all the data can be done right in the browser, which makes these bioinformatics tools more accessible and more comfortable for researchers. So, whether you are a game developer or UI UX designer or data scientist or just web developer who want to level up, there are some gains, some benefits that WebAssembly can give you. And to sum it up, it is like in gaming, you can run 3D games, high-performance games right in the browser, productivity tools like Figma, data science and machine learning like TensorFlow and neural networks and so on, right in your browser. And language portability, you can write in many different languages and don't care about how to interpret it or how to translate everything in JavaScript. So it's pretty cool, right? So now I told you what WebAssembly is, why do we need it, And the obvious question is, what can you actually do with this knowledge? First of all, I want to tell you, don't be intimidated. WebAssembly can sound like some fancy, futuristic technology, but it's really, really super accessible. There are tons of resources helping you to dive in, and I will name some of them. First of all, it is assembly script. If you're already familiar with JavaScript, you can try this one because it is a TypeScript-like language which allows you to write code in a syntax quite similar to TypeScript, but it will compile to WebAssembly directly. So it's making a really smooth learning curve for those who already develop in JavaScript, and you won't have to go too far away from your comfort zone, right? But for those of you who are more adventurous, I would recommend to try using Rust or C. Rust has a fantastic support for WebAssembly. It has tons of resources describing how to start, how to compile your project, and how to do anything, virtually anything. Just you have to read it. And for those of you who write in C, there is mscripting, also a tool that compiles C and C++ code into WebAssembly. Mozilla WebAssembly documentation is also a great resource to get started. It has a lot of step-by-step guides and tons of examples. So take a look if you're interested. But my real challenge for you is just experiment. Try compiling something small into WebAssembly just to see how it works. Or try to take some heavy performance function from your application and try to convert it into WebAssembly to see how much you can gain from that. Or if you have some old project in Rust or C, try to port it to WebAssembly to see how it works on the web. And before I end this session, I already know the most obvious question that many of you want to ask. Is WebAssembly a new JavaScript killer? Well, the answer is no. They actually complement each other, and they greatly work together. JavaScript is still a great language. It's easy to learn. It's fully integrated in the web ecosystem. It's great for fast prototyping and for many other things, for orchestrating everything. But WebAssembly shines in the tasks like scientific calculations, heavy computations, and all that stuff I demonstrated to you already. So they together allow us to create new exciting things and new flexible, powerful web. So the revolution is here, and it's up to us to lead it. Thank you. Now I would love to hear your questions if there are some.
Nick, this was super interesting, so we have lots of questions for you.
OK.
So here's the first one. How does WebAssembly load code that has large libraries as dependencies, like crypto or graphics? Does it support dynamic linking?
Yep. Yep, it does. Basically, it does like everything that typical Rust or C program does, because you write your code in those languages. So everything that is possible in Rust or C or other languages that can compile their code in WebAssembly is supported. So the answer is yes.
Yeah, I had a question, but you answered it. Does it run Doom? Well,
Yeah, yeah.
I got my
It can
answer.
run Doom, yeah.
Yeah, we have a barrage of questions. So there's a question, what is your expectation on adoption of WebAssembly in the future? Won't it be specialized for cases when you really need speed, or will it be adopted for extra security benefits?
That's a good question because I really don't understand. Well, this technology is around for like 5 or maybe 7 years, but it's not really adopted. Well, I understand that not so many tasks require WebAssembly. It's always about something heavy. And I personally use it in some of my pet projects, which is related to some graphics. It's color quantization with some really advanced mathematics in it. It's not based on RGB or something like that. It's more human perceptive things, and the mathematics is quite complicated. So the JavaScript just stuck on that task. It took forever. You know that thing when that pop-up appears, like page is not responding, try to wait or something like that. That happened every time. So I tried to find a solution, and I apparently found WebAssembly and tried using that. And wow, it works. So not that many tasks require WebAssembly, actually, but if you encounter something like that, if you need something like that, now you know what to do.
And we have one more nice question that's getting a lot of likes. Can you access DOM from WebAssembly in any way?
No. Well, there are some ways to allow WebAssembly access to your JavaScript functions, which in turn can access, well, DOM. But usually you don't want doing that because, as I said in the beginning, it's really secured and self-contained, and you do not want to allow it access to your web page or a file system or whatever. You just can use it like an extra function. You pass some data, you get some response. It's not about manipulating the user interface. JavaScript handles it quite well, so yeah.